Imagine waiting nearly 80 years for one of the rarest explosions in our galaxy. This is T Coronae Borealis, better known as the Blaze Star. Astronomers expected it. Millions of skywatchers waited, but nothing happened. So were the predictions wrong, or is something even more interesting happening? A new scientific study tries to answer that question, using history, orbital motion, and the physics of how this star feeds itself. Does the Blaze Star still explode this year, or could we be waiting until 2029? Let's find out. About 3,000 light years from Earth lies a star called T Coronae Borealis. It is one of the most closely watched stars in our galaxy, because astronomers know it will explode again. The only question is when. T Coronae Borealis isn't a single star, it's actually a binary system. One of them is a red giant. The other one is an incredibly dense white dwarf. The giant star slowly loses gas, and the white dwarf steals it. As more hydrogen builds up on the white dwarf's surface, pressure and temperature keeps increasing. Eventually, the hydrogen ignites in a runaway thermonuclear explosion. Unlike a supernova, the white dwarf survives. That's why this explosion is called a recurrent nova. The process repeats over and over again. The last time T Coronae Borealis erupted was in 1946. Before that, it erupted in 1866. That's almost exactly 80 years apart. Naturally, astronomers began asking a simple question: was history about to repeat itself? Then something unusual happened. Around 2014, the Blaze Star entered what astronomers call a high state. It stayed brighter than normal for almost a decade. Scientists believe this meant the white dwarf was accreting material at a much higher rate than usual. It looked like the star was getting ready for another eruption. Then came the biggest clue. In 2023 and 2024, the star suddenly became fainter. That might not sound exciting until astronomers noticed something remarkable. A very similar dip had been recorded just before the 1946 eruption. It looked like history was repeating itself. The excitement spread quickly. Astronomers and skywatchers around the world all began watching the Blaze Star. Many believed the explosion could happen at any instant. But then nothing happened. The Blaze Star stayed quiet, and suddenly one big question emerged. Instead of assuming one clue, this new study took a different approach. The researchers combined three independent pieces of evidence: the star's historical eruptions, its orbital motion, and how its accretion changed over the last decade. Astronomers found an average interval of about 80 years. Since the star still hadn't erupted by July 2026, they estimated there was roughly a 30% chance it would erupt this year, and about a 57% chance within the following year. But these are not predictions, they're simply statistical estimates based on a very small historical record. Next, the team checked whether eruptions happen when the two stars reach a particular position in their orbit. They didn't find one preferred location. Instead, past eruptions clustered around two different orbital phases. That makes these dates useful for planning observations, but not for predicting the eruption itself. The third clue is the most important. Remember the bright period between 2014 and 2023. The researchers argue that this active phase was shorter and dimmer than the one before the 1946 eruption. If that's true, then the white dwarf may simply not have collected enough hydrogen to trigger a nova yet. And that's the fascinating part. Only by combining all three clues can astronomers narrow down the possibilities. So does this mean that the Blaze Star will erupt in 2026, or has the eruption been pushed all the way to 2029? The answer is neither. The researchers consider two scenarios, depending on what the star is doing now. First, the researchers noticed that after recovering from the 2023 to 2024 dip, the star began fading again in 2026. If this renewed decline turns out to be the true equivalent of the famous dip seen before the 1946 eruption, Then the blazed star could still erupt around December 2026. The second scenario tells a completely different story. What if the white dwarf simply hasn't collected enough hydrogen yet? The researchers argue that the active period from 2014 to 2023 may have delivered less material than the one before the 1946 eruption. If that's true, the star may still need few years to build up enough fuel. Under that assumption, the earliest likely eruption shift to around May 2029. The blazed star is helping astronomers test their understanding of how recurrent novae really work, and whenever it finally erupts, that moment will answer questions scientists have been asking for decades. When the blazed star finally erupts, it will brighten by thousands of times. For several nights, a star that normally requires a telescope could become visible to the naked eye. And unlike a supernova, the white dwarf survives, ready to begin the cycle all over again.